In our last few lectures, we have talked about the fundamental features of Python programming. Then we have discussed how to write pseudocode, and we have seen an example of writing a pseudocode for finding GCD of two non-negative integers. Finally, we have written a Python program for finding GCD of two non-negative integers. We will now move toward a Python package that is called numpy or numerical Python. In particular, this numpy package will give us a new data structure. This is the array data structure, and it will help us to perform vectorized operation. What is vectorized operation? That is something we'll discuss later on. In this lecture, we'll talk about creating one-dimensional array using numpy. Basic Python, what we have learned so far, it has limited capabilities for scientific computing. It doesn't have the necessary data structure which are valuable for scientific computing. It is also very slow as compared to C or Fortran, which is a serious bottleneck in scientific computing. To improve Python so that we can use it for scientific computing, we use additional packages. Especially important are numpy, that is numerical Python, and scipy, that is scientific Python. We'll discuss scientific Python later on in this course, but right now we'll talk a bit about numpy or numerical Python. Without numerical Python, it is impossible to do any scientific computing in Python. Numerical Python gives us two things. First one is it gives us this array data structure. This is the data structure that is the engine for scientific computing in Python as well as in any other language. What is array? Array is list of objects, and because it is list of objects, it is like list as we have seen before. But unlike Python list, here array contains same type of data. Python list may have integer, real, string all together, but we cannot have that in array. In an array, if one object is integer, then all the remaining objects will also be integer. If one object is float, then all the remaining objects will also be float. The other point is slightly more esoteric at this point, but that is very important, that they are stored in contiguous memory. So they are stored in a chunk to understand physically, and it helps us a lot in speeding up numerical computing. The second important feature of numpy is that numpy helps us to perform vectorized operation. Now, what is vectorized operation? In vectorized operation, the usual arithmetic operation or mathematical operation that we perform over integer or real numbers, here we will be able to perform that kind of operation over arrays. When we do so, we perform the operation over individual elements of arrays simultaneously. So overall, it speeds up the operation quite a bit. And we will see this example later on. But in today's lecture, we will only focus on creating one-dimensional array. So let us see how it goes. Here we are in our Jupyter notebook, and we have opened up a notebook, numpy fundamental tutorials. I have given certain heading in Markdown, and now we'll try numpy. Because numpy is an additional package, to invoke numpy, we have to first import it. And we are importing numpy as np. This will help us to make our code shorter. We don't have to write numpy all the time. Now, first thing is that creating an array, and that is all we will talk here, creating one-dimensional array. And how we'll do so? A is a numpy array. So we write this as np dot array. Within first bracket, we have to give a list. For instance, 1, 2, 3, 4. This is a list. List is the input. Then what is A? Okay, so we'll run the code and see what is A. You can see here that A is array. This is not a list. This is array 1, 2, 3, 4. What is the dimension of this array? A dot ndim. Usually numpy creates n-dimensional array. So what is that n? We'll find it here. And it gives us 1. So A is an one-dimensional array. What kind of data A contains? Remember that A can contain only one type of data. It contains int 32, so 32-bit integer. We cannot always create arrays just like this. There are many ways of creating arrays in NumPy. So for instance, A is equal to np dot zeros. It will create an array of zeros. How big is that array? It is 4. So what is A then? A is an array of 0, 0, 0, 0. What is the data type? A dot D type. It is float 64. This is a real number. Even though this is 0, you can see that there is 0 point. So by default, it is a real number. We can ask NumPy to create array of real number or float or whatever data type we wish. So for instance, I write A equals np dot, it will create an array of 1. So let us see, it is creating an array of 1 and its data type once again is float. However, we can enforce that it will be an integer array. How to do it? A equals np dot ones for D type equals np dot, assume this is 8-bit integer. You can see that it is giving us D type int 8. You can see data type is 8-bit integer. So we can create array from 0, we can create array from 1. We can also create array without anything. So for example, A equals np dot empty for. So here you see 1, but this 1 are arbitrary. If you run it few times, you may get another number. Let's try something else once again. B equals np dot empty 5 B. You can see there are certain numbers here. These numbers are completely arbitrary. Python has created an array B of size 5 and then it has assigned certain memory location for these 5 elements. In that memory location, whatever are stored, it is being shown here. So in a sense, this is an empty array. Now I want to create another array C which will be like B. That means it would be an array dimension 1 and number of elements 5, but it will not be an empty, it will have 1. So this will be np dot ones like b. So you can see that it has created an array that has 5 elements, 1 dimension, and it is now have only 1. Now when we want to share 2 important features of creating one-dimensional array. A equals np dot arange. This is like the range function, but not exactly the range function. Let us say 6, and we write A. It creates an array from 0 to 5. In Python range function, Python creates a sequence of numbers, but here it is not like that. It is creating an array. It is not just a sequence, it is an array from 0 to 5. So it is like the range function of basic Python, but it is not exactly a range function. It is creating an array. We can use it just like range function. So for example, A equals np dot arange 1 6. You can see that it is starting now from 1 and it is stopping just before 6. Or A equals np dot arange 1 6 2 A. Here 1 is the start, 6 is the stop, and 2 is the step. So in general, this is a function in numpy that would be np dot arange start, stop, and step. The step by default is 1 and start by default is 0. Stop, of course, it doesn't have default. You have to write something very specifically for the stop. And it will stop just before that. So when I write this 1 to 6, it creates an array that is going from 1 to 6 minus 1. Somewhat similar to this, another array creating routine is A equals np dot linspace 0 to 1 4. What does it give? You see that it is giving an array which is starting from 0, it is ending at 1, and it has total 4 elements equidistant from each other. So the interval of 0 to 1 is divided in 3 gaps. Each gap is same as other. So here we have np dot linspace start, stop, and number of elements. So here what is different from all other Python function is probably that you can see that here it is going from 0 and it is ending up at 1. So both 0 and 1 are included. Between 0 and 1, if I take 3 steps, then each of this step will be 1/3, and it will give me 0, 1/3, 2/3, and 1. You can use it for real number of start and stop. So for example, it could be np dot linspace 0.5, 2.5, 4. You can see that it is going from 0.5 to 2.5 and it has 4 numbers. It is creating an array of 4 elements. So number of elements is the last number of this linspace function. One idea of linspace is that if I do not tell it specifically that how many element I want to have, but I give an interval, then what linspace will do is that it will create an array of 50 elements. You can see that between 0 and 1, it has created 50 elements. The size of A, you can see from A dot size, it is 50. So now we close this session. We have learned how to create one-dimensional array in NumPy. If you want to learn more about NumPy, the best resource is you go to numpy.org. That is the basic NumPy website. And they have excellent tutorials and certain other text resources there. You can take a look. As your exercise, create an one-dimensional array of 100 real numbers in the closed interval of 0 to pi. Thank you, and that's all for this session.